So welcome to Maths Memory. This is week 19 and we're going to do this topic, composite and inverse functions, today to show you what this is all about, f of x, okay, and g of x as well sometimes. So let's get a card. This is a grade 8 topic, composite and inverse functions, as we said. Gold tier topic 2. On this card, let's create these sections. The first thing, the learning objectives. We're going to show you how to create inverse functions, okay? So this basically is 3 simple steps. And also composite functions. Composite means 2 functions, okay? Normally f of x or g of x. And we'll show you some tips and tricks on that. Create a space for your best examples you find useful in this video. And hopefully we'll get to 3 steps to make it more clear to you at the end of this topic. Let's turn over to create a new revision card, my toolkit, to show you the best tips and tricks on this video. On a revision card, let's head to this My Toolkit. These are your best methodologies you will find really useful in this topic. So let's section this, section A and section B, and let's get ready to go on these questions on this composite inverse functions. Question 1, back to basics, composite and inverse functions. So let's get you back on this introductory topic. And back to basics, we'll show you now a couple of questions how we utilize these f of x equations, which you're probably not used to. Question 1, press pause please and press play when you have done parts A and B. Now fx equals 3x squared minus 2. Now fx just means y, so if you get confused, think of it like this: y equals fx. This applies for any single thing throughout maths in your GCSE, so just get used to this fact, okay? So if you see fx, think of y, okay? Y equals 3x squared minus 2. So the question is find f of 5 over here. So this simply looks like this. Now if you look at f of x over here, you can see the link. We can see f of x, and then we can see f5. So therefore, this x over here has got to equal the 5 as well, okay? So therefore, we're plugging in 5. Wherever we see x, we're plugging in 5, okay? So we do this. We'll do a bit of bit maths. We'll do the indices first. So 5 squared is 25. 3 times 25 is 75. 75 take away 2. Let's write that down because it seems pretty confusing. So 3 times 5 squared take away 2. The answer is 75 take away 2. The answer is going to be 73. Okay, so it's not difficult, it's just the notation you need to get used to when you see this x. Obviously, it means plug it in that value over here. So the answer is 73 for the first one. Let's do number 2, part B. Same thing, f minus 2. We plug in minus 2. So we've got f minus 2 equals 3 times minus 2 squared minus 2. We'll do the indices first. Minus 2 squared is 4. 3 times 4 is 12. 12 minus 2. Answer is going to be simply 10. So there we go. Very 2 simple, easy questions to get you going on this. And we're going to show you how to do a couple of things like inverse functions and composite functions. Sounds complicated, but we'll show you step-by-step guidance on maths memory how to do this. So make sure you understand these 2 ways of understanding the notation of f of x. And we'll hit on now with our core questions. Question 1, core 1, composite and inverse functions. Let's write this question down, parts A, B, and C. And in particular, we're going to look at how to do an inverse function, the 3 steps towards this. So get your pen and paper down, write this down, and press play when you think you've done the answers. Now, question 1, part A. Let's find the inverse function. This f to the power of minus 1 means inverse function of this function f of x. 4x squared plus 2. So there are 3 simple steps we're going to be showing you over here. So step 1 is this. Let's simply replace y with fx, okay? So wherever we see fx, we're simply going to be writing y. Y equals 4x squared plus 2. Very, very simple. Step 2, let's now make x the subject. So to make x the subject, we're going to rearrange this to make x the subject over here. So I'll do 2 steps in one. I'll take away the 2 on both sides first of all, then divide it by 4. In fact, and I'll do a 3rd step, I'll square root it, and I get x over here. Step 3, we simply swap or replace, should we say, the x's for y's and the y's for x's. So wherever we see the y's, we simply put x, so x minus 2 all over 4, the square root, and this we could write as y, or we could write the same thing as what we see at the beginning, f minus 1x, which is the inverse function. So to really write these down in some sort of way, to make note of these, step 1, you're just replacing y equals fx. Okay. Step 2, you're making x the subject. Okay, and 3, you're just basically replacing x for y and y for x. Okay, so replace, let's say, variables, if that makes sense. All right, so that's how you do part A, inverse function. That easy. Let's now look at question, or part 2 rather. We're going to now be using part A and subbing in x equals 18. And the reason why we know that, this x over here is now x equals 18. So let's use part A into this. We've got the inverse function already. All we do is sub in 18 where we see x. So let's do this. We're going to do f minus 1 18. This is 18 minus 2 all over 4, the square root. And this would give us 18 minus 2 is 16. 16 divided by 4 is 4. Square root of 4 is simply 2. So that is the answer for part B, the inverse function. And you plug in 18, we get a value of 2 over here. So let's plug this in as such. Let's try now part C. It says solve the inverse function of h equaling fx, and it's given us in specifically this thing, h of x equals x minus 1 over 4. So we'll just highlight this over here. So the 3 steps, let's find the inverse function of h. Step 1, let's replace h of x with y. So y equals x minus 1 over 4. We'll do this quite quickly, by the way. Step 1. Step 2, we're going to basically make x a subject. So let's multiply this by 4. 4y plus 1 equals x. And step 3, replace the variables x for y and y for x. So 4x plus 1 equals h minus 1x. Okay, so this is your inverse function over here, 4x plus 1. Inverse function for h, should we say. Now you want to make this equal to f of x. Now f of x is this thing over here, 4x squared plus 2. So let's make them both equal to each other over here. So we have 4x plus 1 equals 4x squared plus 2. Let's get all the x's on one side. We could form a quadratic to make it equal to 0. So 0 equals 4x squared minus 4x, and this would be plus 1 over here, because 2 minus 1 is 1. So we've got this 4x squared minus 4x plus 1. Can we go further? This is an advanced quad box. So we can find two numbers that multiply to get 4, add up to get minus 4. Should be well acquainted with this technique right now. So two numbers that multiply to get 4, because obviously 4, let's say, are these two numbers, the A and the C. This 4 and this plus 1 is the 4. And the minus 4, the two numbers add up to get minus 4 over here. So two numbers add up to get minus 4. Let's call that another color. Perhaps let's call it green over here. So this is this, and this is this over here. So those two numbers would be two minuses. Minus times a minus is a positive. Hence minus 2 times minus 2 is 4. And minus 2 plus minus 2 is going to be minus 4 as well. So if we go to this stage over here, we've got this 4x squared minus 2x plus 1 equals 0. Let's half this in the middle over here. We get 2x minus 1. We'll write 2x minus 1 again over here. And we'll write minus 1 over there equals 0. We'll take the numbers in front of our brackets to make 2x minus 1. And 2x minus 1 again over here. So we have them twice equaling 0. And then the final answer would be x equaling a half. So x equals a half. That's your final answer. There's one solution for this of this equation. On your revision card, section A, let's write this subheading inverse functions. And here we show you a clear 3-step process of how to do this. So make sure you press pause, make note of this, and you get this, okay? This is exactly the question you've done before, and we'll be using this as we go along this video. Question 2, core 2. So let's write down parts A, B, and C. We're going to show you a bit of numbers on how to do composite functions. It sounds complicated, but really it's just an addition onto what we learned before. We're subbing in an equation, or a function rather, into another function, rather than a number into a function, like we've done in the previous question. So we have two separate equations over here. We keep saying equations, functions we mean. All right, so identify this, try to do parts A, B, and C, and press play when you're ready. Part A, so f of g, that's how we say this, f of g. F is this, and g is this function here. Now we used to be doing other, let's say, functions like this, f of x before. You simply have your f function, okay, we'll color this your yellow bit, and we have an x coordinate, I think from one of the questions before. And in this kind of scenario, all you did was substitute your x value into your function over here. Now we have this, okay, so we subbed in a number, NO for number. But now we're doing this, we've got fg of x over here. So we're not subbing in a number, we're subbing in a function. That's the only thing we're doing. We're subbing in a function this time over here. The principle is exactly the same. So if you understood this whole idea of right going into left, what we mean is this. Let's just color coordinate this, by the way, so you understand this. Right goes into left, meaning the g of x function is subbed into your x value in your f function over here. Okay, this arrow right into left is very important. A little shortcut, right into left, right into left. So the same principle we're going to be applying, okay, in this case. So let's write g of x over here. That's what the question is asking. Sometimes we put a square bracket so this thing can be more easily identifiable. So wherever we see x now, i.e. over here, we're going to plug in not a number, but the whole thing we see on g of x, which happens to be x squared minus 2. So 2x squared minus 2 plus 1. Okay, so this bit here is your g of x, which is that bit there. Let's just continue to expand this, the half crab claw. 2x squared minus 4 plus 1, and that gives us 2x squared minus 3. It's that simple. It's the same principle as a normal function of f, but we're subbing in a function into a function. That's why it's called composite, more than one, a composition. Let's do the next question over here. Now g of f. So we have g of f. It's the same principle. So we won't explain this as we did before, but basically we're subbing in this f of x into g. So let's do this over here. We've got g f of x. Wherever we see x over here, we're going to be subbing in this whole thing f of x. So it'll be 2x plus 1 squared, which is 2x plus 1, 2x plus 1 minus 2. Let's do the half or the full crab claw, should we say, on this one. So 2x times 2x, 2x times 1, 1 times 2x, 1 times 1. If we do that, we're going to get this over here. 4x squared plus 2x plus 2x plus 1 minus 2. This leaves us to get to this, which is 4x squared plus 4x minus 1. So that is your final answer for this one. Again, quite simple. It's just showing you the basic principle. We're subbing in f into g this time. Same thing. This goes into this. See, right into left. Always right into left. So let's do this. G f of 3. Now this looks very similar to part B over here. And what we're going to be doing is this over here. We're going to be looking at your f3 over here and subbing this into g. Now, a couple of ways of doing this, but the easiest way of doing this is basically to look at the f function first and subbing in 3. So we're subbing 3 into this over here. 2 times 3 is 6. 6 plus 1 is 7. And therefore we'll do g7 over here. So g7 would simply be 7 squared minus 2. Answer would be 49, take away 2, which would give us 47. That's the easiest way of doing it, okay? So finding out f of 3 first. Another way of doing it, this way only works if you have, let's say an answer for this part over here, i.e. g f of x. We can simply go straight into this and say, okay, if this and this are snap, let's plug in 3 into this. It should make sense. So this is maybe, let's call it alternative 2. Okay, and this is alternative 1 over here. So in this case, what we're doing is this. We're subbing in 3 into the original g of x function. So it's 4, 3 squared plus 4, 3 minus 1. We square this first. 3 squared is 9. 4 times 9 is 36. Plus 12 minus 1. 36 plus 12 is 48. 48 minus 1 is 47. You have a snap with this one. All right, so whatever method you choose, in fact, method 2 might be easier because we already have part B, but we would advise on maths memory to do part, or alternative 1 rather, to get this straight away, because you're not relying on this one to have been done already before that. Look at parts A, B, and C, and make sure you've clocked this, and we'll move on to the next questions. Revision card section B on my toolkit. Let's write this subheading, composite functions. Again, you've just learned how to do a composite function. The best tip on this is to use this arrow we can see over here and replace basically g of x into f of x, if that makes sense. Okay, so you replace an equation which was originally an x actually into f. So right into left. That's the key thing with this. Always the right one. The square bracket into, you sub it into the f of x. Question 2, parts D and E. So let's write this question down and answer parts D and E. We're delving more into this topic of composite and inverse functions. Press play when you have completed these 2 parts. Now this is g and f minus 1x, and this follows the same principle as the technique before on composite functions. Basically, we can put a square bracket here if you want to differentiate the g and the f minus 1. This simply means we're subbing in the inverse function of f into g, right into left. So first of all, let's find out what f minus 1x is, or the inverse function. Step 1, let's replace fx with y. Y equals 2x plus 1. Step 2, let's make x a subject. So this will be y minus 1 over 2 equals x. And step 3, let's replace the x's and y's. X minus 1 over 2 equals f minus 1x. There we go. We've got our inverse function of f. Now this we want to plug into basically g. So this thing over here, let's highlight this. This whole thing over here we're going to plug into now. Or in fact, let's make it a different color. Let's make it green. In fact, we're going to plug this into, that's the same thing as this, into g, okay, which is the yellow one. So let's look at this. So wherever we see this x over here, we're going to replace it with this x minus 1 over 2. So we have x minus 1 over 2 squared, and this is take away 2. Let's square the numerator and denominator separately. So we get this x minus 1, okay, all over 4. I'm squaring the bottom bit over here. Take away, we'll write 2 over 1 so we can create a fraction in a second. Let's now go into expanding this to crab claw. We're going to get x squared. We'll do 2 steps in one. Minus x is minus 2x, and minus 1 times minus 1 is plus 1, all over 4, and this take away 2 over 1. Let's now simply do the camping method on this. We can do this because we're adding, or taking away rather, 2 fractions. 4 times 1, 1 times that top left numerator, and 4 times minus 2. So we get this. We get 4 as your big denominator over here. We get x squared minus 2x plus 1 and minus 8. This leads us to, if we carry on over here, x squared minus 2x minus 7 all over 4. So that would be a final answer for this. We can't go even further, but that would be what this answer would be over here. Let's just put this into a square so you don't get confused on that. Question 2, part E. So let's now do the last final question on this. Again, this is quite a difficult question. Okay, so it's 2g of x equals f of gx. Show that 6x squared plus 8x plus 1 equals 0. So show that means basically we're meant to derive it from doing the question over here. Do not play with this or manipulate this equation over here or work backwards. Just try to play snap, as we say. Try to derive it from here and it should equal that. Snap equals snap. So let's do g of x. Let's remind ourselves what g of x was over here from the first earlier parts of this question. So g of x was simply 4x squared plus 4x minus 1. And similarly we have f of gx. This was 2x squared minus 3. Now 2g of x just simply means we'd multiply this by 2. So nothing hard about that. It's just simply multiplying everything there by 2. So we get that it's 2, 4x squared plus 4x minus 1. And that equals 2x squared minus 3. Let's expand these 3 steps as such. So we get 8x squared plus 8x minus 2 equaling 2x squared minus 3. Let's take over the 2x squared to make a minus 2x squared. So we get 6x squared. If we take it away, we're still left with 8x over here, the only x term. And minus 2 plus 3 is going to be plus 1. So do we have snap? Well, I think we do, because if you look at this, this over here simply equals that. We've derived it from this first source over here, but more importantly, we've linked it to show what originally meant. So that's what the word show that means, and we've done it quite simply. It doesn't say to solve it, but just to state what the answer is. Question 3 challenge. Let's write this question down now, part A, and find the values of A and B for both of these different kind of functions, f and g. Press play when you have completed this question. Now let's read the question. It looks quite complicated over here, but really if we split this down and then the technique to use, it's not that bad at all. So g of 2 equals 10. Okay, that's the first kind of statement we're given over here. And f minus 118, or the inverse function of f 18, equals g of 1. Let's look at this and let's try to sub in what we have so far step by step. So g of 2 equals 10. So that means we sub in wherever we see x, we plug in 2. So if we do that, we're going to plug in 2 on here. We get a2 or 2a. So g2 equals 2a plus b. We can't go any further. We'll leave it like that. That's the first step over here. We've dealt with the first kind of statement over there. We'll call that a yellow one. Let's look at the green one over here now. So we have this inverse function of f and then 18. So let's first of all plug in or find for it first of all the inverse function of x. The 3 steps. Step 1, we'll call this y. Y equals 4x plus 2. Step 2, we'll make x a subject, so it'll be y minus 2 all over 4 will equal the value of x. Step 3 will simply replace x for y and y for x. Okay, the variables. So x minus 2 all over 4 equals f minus 1x. So this is our inverse function over here. That's to do with this statement, the second statement, so we'll call it green. Okay, this is what we have over here. Now you want to actually plug in 18 into this, because that's what the question is asking. It's saying x is going to be 18. All right. So if x is 18, because of 18 over here, we'll say basically that 18 minus 2 all over 4, that's the same thing as the inverse function of f, and that should be 18, like that. Okay, so we get 18 minus 2 divided by 4 is simply 16. So f minus 118 will give you 4. Okay, so we've got that. Now this equals g1. So g1 simply is like wherever we see x, we're going to plug in 1. So g of 1 simply equals a times 1, or 1a, or simply a plus b. So we have that equation over here. So let's put the two together now. Let's see what we can do with the yellow color and the green color together and what they look like. That's very important to identify what they look like. We have this. We have basically Sorry, this equals 10 in fact. We forgot to put that. That's the 10 over here. So we have this over here, 2a plus b equals 10. Now that looks like a simultaneous equation, first of all, okay? So if we have this in the same format over here, it'll be really good. So in this situation, we have 4 equals a plus b. We could put equals 4 there from this result. So a plus b equals 4. So we have number 1 and number 2. It's definitely a simultaneous with elimination. So we'll get rid of our a's or b's, and in this case it's easy to get rid of the b's. They're both the same. We'll take them away. Take. 2a take away a is a. These cancel. 10 take away 4 is 6. Therefore a is going to be a value of 6. We simply sub in this a equals 6 back into any one of a or b, whatever looks easiest. In this case probably number 2 does, so it'll be 6 plus what gives you 4. B hence would be minus 2. So sub into number 2, we've got 6 minus 2 will give you 4. That's what you want, hence therefore b would be minus 2. So that's your answer. It'll be a is 6 and b will be minus 2. We found out the values of a and b via simultaneous equations. So we have come to the end of this topic on functions. Let's make sure we have these things completed. So do you understand inverse functions? Do you understand the 3-step process towards that, and how to understand what the question is asking? F of x to the power of minus 1. That's the notation for that. Do you understand composite functions, 2 functions, and how to substitute one into the other and then simplify and expand it at the end? If you understand that, we say g of x or f of x, depending on what you're trying to do. Give yourself a tick as well over here. All your best examples in this video as well could be any single thing you found of value. Write it over here. And obviously 3 steps we cannot get because this topic is quite challenging, should we say, and quite varied. So it doesn't make a difference. Let's turn over to get our completed toolkit, so you are in good hands for using this card during your Let's Do It questions. So these are our key concepts we have learned during this video. Inverse functions, the 3 steps for this section A. Section B as well, composite functions, how to spot this and how to apply this as well. So let's make sure we've got these methodologies and these top tricks, and we're going to use them in our Let's Do It questions in a second. Question 1, let's do it. Now let's use our revision cards, the great opportunity to apply your knowledge from the exam style questions on, let's say, inverse functions and composite functions. Make sure you know your steps and can understand your toolkits. Let's apply it into action straight away into parts A, B and C on this question 1. Press play when you are ready. Question 2, let's do it. So let's now prove to yourself how good you are in this topic, and let's apply what we've learned so far again in your revision card. So write parts A and B down please on a piece of paper, and let's try what you've got. Press play for the answers when you're ready. Question 3, let's do it. So let's get a chance to now write parts A and B again, and let's use our cards to solve and answer these questions on these 2 parts. Press play when you have the answers. Well done on completing this topic on composite inverse functions. We have now hit week 19 on that planner of yours. This is a gold tier topic. So again, a grade 8 solid topic you've just finished. So how well do you think you've done on this? How well have you done your Let's Do It questions, and how well have you understood the key principles on these 2 key concepts of inverse functions, i.e. the 3 steps we talked about, and composite functions using g of x and f of x and subbing one into the other. If you've understood this and you've done your questions really well and used your revision cards to do this, let's give yourself a mark out of 10 on your revision planner on week 19.